Okay, got another paper 2 question. Going to use a little bit of calculus on this one, but a lot of it can be answered on the TI-84. So that's this portion of the video. I'll do the calculus written portion in another video. Okay, so look at this question from 2016, paper 2, time zone 1, 13 points. Okay, we got a ship shooting a distress flare into the air. The height in meters is modeled by the following quadratic equation, which is true because this is like a ballistics problem. It's going to shoot the flare up into the air and it's going to come back down to the water. Okay, T is the time in seconds, and T is equal to 0 is when the flare is fired. Write down the height from which the flare was fired. Well, T equals 0. So you're trying to find H of 0 here. Negative 0.2 times 0 squared plus 16 times 0 plus 12. These two terms become 0. The height is 12 meters at 0 seconds. Okay. Find the height of the flare 15 seconds after it was fired. Well, we're going to have to put 15 in for T in the function. So you got 15 squared here, and you got 15 here. And it might be better at this point to switch over to the calculator. So put in your function. Again, you use the y equals key, and we're going to put in negative 0.2. And then t squared, I'm just going to say x squared, okay, for my variable. And then plus 16x, which actually is the initial velocity. It's shot up into the air. Where it landed, I know not where. Okay, and then that's my function. And I want to find the time, or I want to find the height, excuse me, at time 15. I can get it off the table if I wish. Okay, look at the table. Don't have any negative time. Look, t equals 0. The height is 12. Right there. Okay, now I want to look at t equals 15. Okay, I could calculate it manually, or the calculator's already done it for me. 207 meters at 15 seconds. Okay, again, I can put it in manually. I can also use the vars button because I've actually programmed the function into y1. So I want to use, perhaps I want to use the function. So I'm going to do y-vars function y1 brackets 15. This is the height at 15 seconds because I had put in the height function in the calculator in y1. Okay, so I have the answers to A and B. Okay, the flare fell into the sea k seconds after it was fired. Okay, so what is the height of the sea? Height up here is going to be 0. Okay, so you're solving this quadratic equation for when the height is 0. We're going to have to solve this graphically. You could use the quadratic formula. Okay, you put in 0 here, and then you have A, B, and C to use in the quadratic formula. We can do that written later. And then we're going to find the value of k when it came back down into the sea. All right, so I wanted to show you that if we look at the graph of the function, what the heck is going on here? There's no parabola. So you're going to have to zoom out to see the parabola, or you can try zoom fit like we talked about before. See what that does for us. I think it's 0. Yeah, it's 0. Zoom fit. Not very helpful. I only see the beginning of the parabola, and actually I might be able to see that the height is 12 at t equals 0 here. So this is it going up. We need to find it coming back down. So I'm going to zoom out and take a look at it. So when you hit the zoom out key, it's going to zoom out on, right now it's on the origin. Maybe I want to move to the right. Okay, and zoom out over here. So it's going to zoom out on the cursor. All right. And when I hit enter, it zooms out. Not there yet. I think I'm going to look a little bit further to the right. Try and get a complete picture. Okay, well, that's pretty darn complete, but not the best window size. So again, I can see the flare going up in the air and coming back down to the sea. Where does it come back down to the sea? At 0. Okay, so I can change the window size, make it a little bit more visible if you'd like. But I want to just try and find this 0 right here. So I go to second, trace to 0. Okay, and then I want to go to the left and the right of the 0. Okay, again, there's a 0 over here, but that's in negative time territory. That doesn't exist. So we're not going to look for that 0. We're going to look for the positive 0. Okay, I'm to the left. Y is 278. That's the height of the flare there at 56 seconds. I'm going to try and get through 0, so I have to look for a negative height. Okay, I'm through 0 on the height. I got a negative height. I hit enter a second time, and you can see my brackets of where I'm looking for the 0. In between those two, again, I can get closer to the 0 if I want, you know, and then I hit enter the last time, and it will jump to my 0. So y is equal to 0 at 80.7 seconds. Okay, that's using the calculator to solve that. Okay, h prime of t, that's finding the derivative function. So I'm going to do that later. 2 times negative 0.2 t to the first power, 1 times 16 t to the 0 power, and then there's no derivative of 12. It doesn't vary with respect to time, so derivative of 12 is 0. Okay, show that the flare is reaches its maximum height at 40 seconds after being fired. Okay, that is actually the vertex of the parabola. So you can use the vertex formula from the formula sheet if you wish, wherever the formula sheet is. Okay, which is negative h over, h is equal to negative b over 2a. You can use that to find 40 seconds at least, okay? And then later you're going to be asked to find the maximum height. So you're going to need to put 40 into the original function, square it, and multiply it and add it and all that. And we know how to do that. It's directly on the calculator, or I can just look on the table. Another way to do it, which is why I'm here on the MacBook, is to show you that I can find this maximum here, even with my my poor window size. I can find the maximum of the parabola, which is the vertex. So I just look second, trace, calc, maximum 4. Same idea. I'm going to have to go to the left side of the maximum and the right side of the maximum. So I'm moving my cursor to the left of the maximum. I hit enter. I get the little arrow up top. Moving the cursor to the right of the maximum, enter again. Now my calculator is looking for a maximum between these two x values. Okay, so it's going to do trial and improvement and find the maximum y in between those two x values. There's only one maximum in there, but I still like to get up closer to it. So I move the cursor closer to the maximum. That's my guess. The computer's going to start guessing there and searching for the maximum y. Okay, the calculator. Oh, it's pretty close. So at 40, it is at 40 seconds. That is the vertex. You could say the vertex. And y is 332 meters, 1,000 feet in the air, more than 1,000 feet in the air. Okay, so you have the answers to EI and double I. Okay, from the calculator. You can use calculus also to solve that problem in addition to the vertex formula. Okay.